Hi, I'm Janne. Today I'm going to demonstrate how to implement a simple flashlight with LED using the Raspberry Pi devices in Oulu Garage Innovation Laboratory. So here we have one Raspberry Pi set, and when we open this box we will see that we will have lots of small devices which we can connect to the Raspberry Pi plus the Raspberry Pi device itself. Now the first thing we need to do is to connect this Raspberry Pi device to keyboard and mouse and monitor, and also then connect this one to the power source. So the first thing to check is that the hard drive for this Raspberry Pi is in place. So this one uses just a small micro SD card as its hard drive, and it's there, so we are good to go. So now we can start connecting the other peripherals. So one important thing to remember is to contact the power source last, because it starts to boot right after we have connected it to the power. So let's start by plugging in the keyboard and mouse to the USB connectors here, like this, and then we will connect the monitor to the HDMI connector. Let's also turn the monitor on. Okay. Next we need to connect something to play around with, and as I said, today we are going to implement a blinking LED. So let's take a LED, and these Raspberry Pis here in the Oulu Garage, these are equipped with this kind of connector board which is on top of the Pi, and this board makes it much more easy to connect devices to the general purpose I/O pins of the Raspberry Pi. So the normal gpiozero pins are here, but because this has the connector board, they have been brought here. So now we want to connect a LED, and here on the connector board we have like two segments. There's a segment for digital general purpose I/O, which are these connectors, and then there is also segment for analog input ports. And as LED is kind of digital one, it basically only has two states, on and off, so we want to connect to the digital ones. And I will be using this D15 connection here, which means that it's the I/O pin 15. It actually also has the pin 16, but because LED only uses one signal, so it's actually connected to the D15. So now our LED is connected, and we are almost good to go. And now the only thing we have to do is to plug the Pi to its power source, and as I told, it immediately will start to boot. We can see it from the monitor, hopefully. Yes. You can see the boot up screen of the Raspberry Pi here. It goes blank. It actually stays blank for a quite long time. You need to be patient. Now, if you want to connect to the internet while doing the exercises, make sure that you are connected to the Nokia Guest network. So select from the network menu Nokia Guest and wait until it gets a connection. Now, and when the connection is on, you can open the web browser And you can try to go to some web page, but most likely it doesn't work. Like here, it tells that the site cannot be reached. It works if you say www.nokia.com and hit enter. You go to the authentication page of the Nokia Guest Access. Actually, there's no need for any authentication. You can just press connect here. And from now on, the internet access works. Okay, now we have our Raspberry Pi connected and it has been booted up. So we are ready to learn how to use Python programming language to control the LED we have connected to our Raspberry Pi. This exercise is very similar to what is in raspberrypi.org in physical computing with Python worksheet, so you can take that as a reference if you wish. So here is our connection to the Raspberry Pi, and the first thing we want to do is ensure that everything is okay with our connection, and we will do that from the command line, from the terminal. So if you click here, you get the terminal open, and I will bring it to the right side, to this corner. Now if you type Python 3, you get the Python 3 interpreter started. Now we should control the LED from the Python 3 interpreter. The easiest way for doing so is to load a library, a Python library for controlling the general purpose I/O for Raspberry Pi. So we import gpiozero library. And then the next thing we need to do is to create a LED object. So we want to create a LED object. I will call the object red because I have red LED here. And then I say gpiozero.led. And as an argument for the object creation, I need to give the GPIO pin number for the pin where the LED is connected. So it's connected to the pin number 15. So I give that as an argument for creating the LED. Now I have the LED object, and now I can try if everything works. So I can say red.on, and the braces for calling the on method. And when I hit enter, the LED is lit. And then I can of course also say red.off, and when I hit enter, the LED goes off. Okay, so we have everything connected and it seems to work. For really implementing the blinking LED, we don't want to do it here in the interpreter, because if we make a mistake while typing, we always need to retype, and that's kind of stupid work. So let's type exit and braces to get away from the interpreter. And now we need to figure out the place where we want to make our work. Basically, we need a file where to write our Python script for blinking LED. Now we are in the home directory of Raspberry Pi. And let's go to the documents directory, say cd documents. When you hit tabulator, you don't need to fully type, you can just hit tabulator, so you get partial word filled. And when I say ls, I get the contents of the directory. There are some stuff here, but there's no suitable directory for my LED, so I create a new directory for my LED implementation. So I say mkdir LED, and then I go with cd to the LED directory, and I say ls to confirm that it's empty. Of course it's empty. And now we want to use a text editor to create our Python file which will implement the blinking LED. So we go here to the Py menu, to the programming menu, and then we open Geany Programmers Editor, and we click that, and we get the editor open. Let me sort the windows a bit. And now we write our script here in the editor. Basically, we can almost copy, or we can actually copy what we wrote in the interpreter. We anyway need the gpiozero library. We need that library, and then we need to create the LED object again. And it's still connected to the GPIO pin 15. And then we want to turn the LED on. And yeah, now I tried to save by pressing Ctrl S, and because the file doesn't have any name, we need to choose the directory which we just created for our work, so this directory, and choose a name for our file. So the directory I easiest find if I go to first to this directory, which has kind of house and PI. It's the home directory of the PI user, which is the default user for the Raspberry Pi. And then I go to Documents and LED. And I name the file as led.py. Like this. And then I say save. And now I can try to run my Python script. I can type python3 led.py, and when I hit enter, there's very brief blink of the LED. But then it goes away. And it goes away because after turning the LED on, the script actually ends. And when the script ends, gpiozero library cleans up and turns the voltage on all GPIO pins off. So to have it on for a while, I need to do something extra. So let me import another library called time. And if after turning the LED on, I will say time.sleep, and here as an argument I need to say how long time to sleep. Let's sleep for 3 seconds. Now I again pressed Ctrl S to save the file, and I run again. And as you see, the LED was on for 3 seconds and then it shut down. Now we are getting closer to what our goal was for today. So our goal was to implement the blinking LED. So now what we basically would need is to turn the LED on, then sleep for 1 second, for example, and then turn the LED off, and then sleep for 1 second, and then turn the LED on. Well, we can create some blinking with this one also. But if we would want to create blinker which blinks forever, we would need to type horribly a lot. So basically what we would like to do is to be able to repeat these lines forever. And to be able to repeat something forever, we need some kind of loop structure. Python has two loop structures, while and for loop. While loop is more suitable here for creating a forever loop. You create a while loop in Python by typing while and then the condition for the loop. So basically the loop is run as long as the condition is true. If you give boolean true as the condition, then the loop is run forever. And by convention in Python, blocks start with a colon and an indent. So we want to mark that these lines are the lines we want to repeat in this loop. So we want to make them a block in the code. So what we do is put a colon and then indent these lines, which are part of our code block we want to keep repeating. And then the block ends when the indentation level is gotten back to original one. Here our file ends, so that is not so visible. So now if I run, I think I will have a forever blinking LED. Let's see. Okay, now because it's blinking forever, we need to press Ctrl Z to stop blinking. We are almost ready for today. One thing which is not actually adding any new functionality, but which is good for our future exercises where we start to do something more complicated, is to create a function for blinking. So if I would want to do blinking in some other file, for example, then it would be useful for me to be able to just reuse the blinking and just say blink, and I would get a forever blinking LED without repeating the stuff we had here. So basically here I wrote a call to a blink function which doesn't exist yet. So now what we want to do is to create a function out of the code we wrote directly to the body of this Python file or module in Python terms. So if I want to create a function, I started by typing def, which tells to the interpreter that now we started a definition of a function. Then I type the function name, and then in braces I put the arguments to the function. Like here below you see that sleep function, for example, takes one argument, which is the time in seconds for how long to sleep. For my blink I don't take any arguments, so I just put a closing brace after opening brace. And to get all this stuff to be part of the function body, I need to indent it. Because like I told while talking about while, the Python block rules work so that the block starts with an colon and an indent, and then the block ends when the indentation level goes back to the original level. So here my blink function ends after line 12. Okay, now I press again Ctrl S to save, and I can rerun, and it works exactly the same as it used to work. Good. Thanks for joining. This was everything for today's session. As I said, this is almost directly based on what you can see in raspberrypi.org in physical computing with Python. And then the other resource you you might want to use is the gpiozero documentation for Raspberry Pi. Okay, thanks for joining. Bye bye.